Welcome to Hashi Talks. Hello everyone. Thank you for joining me today. I'm excited to share my presentation on demystifying Kubernetes networking using Terraform. In this session, we will focus on understanding the complexities of networking within Kubernetes and how we can simplify these processes using Terraform. Our goal is to make networking concepts more accessible, especially for application developers who may find these topics daunting. We'll explore the basic principles of Kubernetes networking and the common challenges developers face. We will also discuss how Terraform can help automate and streamline these networking configurations, making your workflow more efficient. This presentation will last approximately 20 minutes. Let's dive in and start demystifying Kubernetes networking together. Thank you for being here, and I look forward to an engaging session ahead. A quick introduction. My name is Akshat Mohan Awasthi, and I am from India. I have been working with Google for 5 years now, and I work as a technical solutions engineer with the cloud networking team here. My team's vision is to simplify networking for users through infrastructure as code tools such as Terraform. Prerequisites. Before we dive in the main content of our talk, let's discuss the prerequisites that will help you get the most out of this session. Familiarity with key concepts. This presentation assumes that you are already familiar with several foundation topics. Nodes. Understanding what nodes are in a Kubernetes cluster and their role in hosting pods. Pods. Familiarity with pods, the smallest deployable unit in Kubernetes. Cluster IP. Knowledge of how cluster IP works to explore services within the cluster. Services. Understanding the concept of services in Kubernetes and their purpose. Node IP ranges. Awareness of how IP ranges are assigned to nodes within the cluster. Pod IP ranges. Familiarity with how IP addresses are allocated to pods. Additionally, please ensure that Terraform is installed on your machine. This is crucial as we will be using it to manage our Kubernetes networking configuration effectively. Having a solid grasp on these topics will enable you to engage more deeply with the material that we will cover today and understand how Terraform can simplify Kubernetes networking. In this talk, we will explore the complexities of Kubernetes networking and how Terraform can be utilized to simplify these challenges. To start a story, actually, a couple of years ago, I was a bright-eyed, fresh graduate student, ready to conquer the world with my coding skills. My first task, deploying our new microservice to the Kubernetes engine. Kubernetes, they said, was the future. Scalable, resilient, the platform of champions. Easy peasy, right? Famous last words. I dove headfirst into the tutorials, wrestled my way with YAML files, and finally, triumphantly, deployed my application. It worked locally, but when I tried to access it, nothing. Crickets. My service was lost in the Kubernetes jungle. Turns out, Kubernetes networking wasn't as intuitive as I hoped. Services, ingress, network policy, cluster IP, secondary IP ranges. It was a whole new language I hadn't signed up for. I spent my days grappling with cryptic error messages, tweaking configurations blindly, and feeling the creeping dread of imposter syndrome. I mean, I was a developer, not a network engineer, right? Surely there had to be a simpler way to get my application talking to the outside world without needing a PhD in network topology. That's when I discovered the power of Terraform. Kubernetes is a powerful orchestration tool for managing containerized applications. Sure, but its dynamic networking model can often lead to issues such as IP exhaustion and improper cluster provisioning. By leveraging the capabilities of Terraform's infrastructure as code, we can automate the provisioning of Kubernetes cluster, their networking components, reducing manual errors and enhancing operational efficiency. About Terraform. Terraform is an open source infrastructure as code tool. It allows users to define, provision, and manage cloud and on-prem infra through declarative configuration files. By using HashiCorp's configuration language, HCL, Terraform enables teams to automate the deployment of resources across multiple cloud providers, including AWS, Azure, and GCP, as well as on-prem environments. Why use a Terraform, you ask? Mm, Terraform allows for the management of resources using code, making it easier to version control, share, and collaborate on infra changes. Multi-cloud support. As with Terraform, users can manage resources across various cloud providers and on-prem environments from a single platform, providing flexibility and reducing vendor lock-in. Users can specify the desired state of their infra without needing to outline the steps to achieve that state. Terraform automatically determines the necessary actions to reach the desired configuration. You ask the key benefits of Terraform? Consistency and reproducibility. Infrastructure can be provisioned consistently across different environments, dev, staging, prod, using the same config files, reducing discrepancies and errors. Automated resource management. Terraform automates the entire life cycle of infra management, including creation, generation, updation of resources, resulting in increased efficiency. Execution plans. Before applying changes, Terraform generates an execution plan that outlines what actions will be taken. This allows users to review changes before they are implemented, minimizing the risks. State management. Terraform maintains a state file that tracks the current status of managed resources. This helps in ensuring that the actual infra matches the defined configuration. Collaboration and version control. By storing configuration file in version control systems like Git, teams can collaborate more effectively and maintain a history of changes made to the infrastructure. In summary, Terraform empowers teams and developers to manage their infra efficiently and predictably while enhancing collaboration and reducing operational overhead. Goals of this presentation. In this section, I actually wanted to outline what are the main goals of this presentation today. Understanding these goals will help you grasp what we aim to achieve together and set the correct expectations. The first goal is to understand the challenges of Kubernetes networking. Kubernetes networking can be complex due to issues such as pod-to-pod communication, service discovery, IP address management. We'll discuss common problems that developers face, such as network congestion, misconfigured policies, and the dynamic nature of containerized IPs. Second, demonstrate how Terraform can actually address these challenges. Show you how Terraform is a powerful way to manage infra as code, allowing for automatic and consistent networking configuration. And third, provide practical examples of using Terraform to configure networking for Kubernetes cluster. We will actually be using the cloud networking configuration solution GitHub repository, which is an open source repository for users to actually set up networking components to use different cloud services. I will walk you through specific use cases, configurations, showing you how you can apply these concepts in your own environments. These examples will help solidify your understanding of both Kubernetes, networking, and Terraform capabilities. Common issues faced with Kubernetes networking. When configuring networking for Kubernetes engines, various issues can arise that may affect connectivity and overall performance. Here are some common networking issues that I have seen users faced. Incorrect network resource provisioning. Misconfigured network resources such as VPCs, firewalls, load balancers can lead to connectivity issues among pods, between external services, or not even let you spin up a node pool in your Kubernetes cluster. This definitely leads to pods being unable to communicate with each other or external APIs, relating to application failures for developers. incorrect Kubernetes configurations. Errors in Kubernetes configuration files, like YAML manifests, can lead to improper service definitions or incorrect network policies. This could create issues such as DNS failures, where pod cannot discover services, or service discovery issues due to mismatched selectors. Complex IP address planning. Managing IP addresses across multiple clusters, services can become really complicated, especially with overlapping CIDR ranges. This complexity can lead to IP exhaustion, where no more IP addresses are available for new pods, or conflicts that prevent communication between services. IP exhaustion. When a number of available IP addresses in a subnet is depleted, new pods cannot be assigned new IPs. This results in deployment failures and can hinder the scaling of applications altogether. We should actually plan IP addresses properly beforehand. Kubernetes cluster control plane connectivity issues. Pods or nodes may fail to reach Kubernetes control plane due to misconfigured network settings or firewall rules. This can disrupt management operations and affect the cluster's ability to respond to requests, leading to degraded performance. Internal communication problems. Pods may be unable to communicate with other pods or services within the same network. This could stem from network policies blocking traffic or issues with underlying network plugin, resulting in application downtime. External communication issues. Pods might struggle to access external resources due to misconfigured NAT or maybe incorrect firewall rules. Services exposed via the Kubernetes load balancers may become inaccessible from outside the cluster, affecting user access and functionality. Firewall and network policy misconfigurations. Incorrectly set firewall rules or network policies can inadvertently block legitimate traffic. This leads to connectivity issues between pods or prevents access to necessary external services. Solution. The Cloud Networking Configuration Repository provides a set of Terraform modules specifically designed to streamline the setup of Kubernetes networking. Key features include automated provisioning, where users can define their desired infrastructure state using Terraform's declarative language, HCL, allowing for consistent and repeatable deployments across various environments. Integration with Kubernetes resources. The repository facilitates the management of both infrastructure and Kubernetes resources in a unified workflow, enabling seamless scaling and configuration changes. Enhance visibility and control. By utilizing Terraform's state management capabilities, users can track changes and detect configuration drift, ensuring that their Kubernetes networking remains aligned with the organizational requirements. Provisioning Kubernetes networking with Terraform. It gives out the benefits of simplified setups for application developers, a simple unified infrastructure management. Terraform allows you to define and manage your Kubernetes clusters and networking components in a single config file. This creates a cohesive environment where infra and application deployments are streamlined. Declarative configuration. With Terraform's simple declarative syntax, developers can specify the desired resource states, may it be for Kubernetes or may it be for networking resources. This means you just need to describe what you want, and Terraform takes care of how and managing the provisioning of resources efficiently. Automated resource management. Terraform automates the life cycle of your Kubernetes cluster and also some of your networking resources. You can easily scale your cluster by adjusting node counts or types in your configuration file and applying changes with minimal downtime. Provisioning Kubernetes networking with Terraform. In this section, we actually discuss how to provision Kubernetes networking using Terraform. It's a crucial step in setting up your Kubernetes environment effectively. To share some of the resources that are created as a part of the automation, which are specific for networking. These include VPCs, VPCs are a private network dedicated to your Kubernetes cluster, providing isolation from other networks and allowing you to define a network topology. Subnets are segments of your VPCs that allow you to organize resources based on availability zone or specific functions, enhancing security and performance. Firewall rules. Firewall rules control the inbound and outbound traffic to your resources, ensuring that only authorized connections are permitted. CloudNAT. CloudNAT allows instances in a private subnet to access the internet while keeping them secure from inbound connections. Identity and access management policies define permissions for users and services, ensuring that only authorized entities can access or modify your Kubernetes resources. Primary and secondary IP ranges. These ranges are used for assigning IP ranges to your pods and services, facilitating communication within the cluster while avoiding IP conflicts. Importance of these resources. Each of these resources play a very vital role in establishing a secure and efficient networking environment for your Kubernetes cluster. By automating the provisioning of these components with Terraform, you can ensure consistency, reduce manual errors, and speed up the deployment process. In conclusion, understanding these resources is also a key for leveraging Terraform effectively for your Kubernetes networking. As we proceed, I will provide practical examples on how these components come together in real-world scenarios. This is a quick diagram on what we will be creating as a part of our example. Here, just for an example, I have used GCP as my cloud provider. However, for Terraform, you can use any other cloud provider such as Azure or AWS, or actually use the power of Terraform for an on-prem setup as well. Here, there is a consumer or a customer's Kubernetes project. They have a VPC, which is a network, and inside that network, there is a GKE cluster. Inside the cluster, there are nodes which would be parts of node pools, and these nodes have the smallest deployable units, which are called pods. Now, a customer can actually connect to this GKE cluster using gcloud, a compute engine instance, or the kubectl command. Now, we will quickly demonstrate the solution that we are trying to explain. To share the Cloud Networking Configuration Solutions repository, this is how it looks on GitHub. It has a couple of essential folders which have all the right amount of documentation that are required. There are the configuration folder and the execution folder that we would be mainly focusing upon. The configuration folder is basically for your TFVAR files or your YAML configs for all your producer and consumer resources. And the execution folder holds the logic which will be used to actually provision these resources. I have already cloned this repo in my local environment and would be showing you an example of what we would be doing. So this is my repository which I have cloned. Here in the organization.tfvars, I have given my project ID and given the APIs that I will need to enable to use my solution. Actually, after going from an organization stage, I will move to the networking stage. In the networking stage, I have given my project ID, the region, the network name, the subnet that needs to be created with an IP range, the name of the subnet, the region of the subnet, and the secondary IP ranges with their IP address CIDR ranges, name and the CIDR range of what I want to create. Rest, apart from CloudNAT, I'm not using an HAVPN, an interconnect, or NCC, which are different networking solutions from Google Cloud. As it does not relate to us, we would not be discussing them at all. Next, in the configuration folder, inside the producer folder, there is GKE. GKE is Google's Kubernetes engine. To simplify Google Kubernetes engine provisioning using these networking resources that we would create, we have created an instance.yaml. Now, this instance.yaml is simply a declaration of how I want my GKE cluster to look like. I want its name to be this. This is the network that I will be using. This is the subnet I'll be using. This is the IP range for pods, IP range for services, the Kubernetes version, and putting the deletion protection as false. Now, what I can simply do is that inside this execution folder, there is an automation setup. This run.sh is simply a quick shell script that can help you run different stages of setup through simple commands. So what I will do is I want this run.sh to go through all stages, which means that it should enable the APIs, it should create the networking resources, and then it should spin up a GKE cluster. It should do that in the exact order and not change the order of these setup steps. Because a GKE cluster will require the networking resources, and the networking resources would require the APIs to be enabled correctly. So, and -s, which stands for stage, all, and then a -t for which Terraform command I would like it to run. So -t, init apply. Now in init apply would go step by step from bootstrap to organization to networking to security to producer folder and create all the resources that I require. Now I will actually run this command and meet you after my resources have been provisioned. Welcome back. As you can see, our GKE cluster is now created. So just by one single command, we could actually enable all APIs, create all networking resources, and create a GKE cluster. Looking at the Cloud Console, we should be having our GKE cluster created with the required node pools and nodes. This is our GKE cluster, which has two node pools. Okay. And then this node pool should have all the required networks, subnetworks, IP ranges. So now it was very simple for me to spin up a GKE cluster, spin up all networking requirements, enable the APIs as required. This is the VPC or the network that got set up using Terraform, as you could see. This VPC has one subnet and would have all the required networking configurations which my GKE cluster would use. Coming back to our presentation, this was a quick demonstration of our repository. You can scan this QR code or go to the link to actually check it out furthermore. There are multiple README documentations or guides to help you try it out and set up GKE applications without worrying about the networking components using Terraform. To summarize, simplifying Kubernetes networking is crucial for effective application management as deployments scale. By leveraging Terraform capabilities, organizations can automate provisioning processes, reduce complexities, and focus on application development rather than intricate networking configurations. This talk aims to equip attendees with practical solutions that empower them to navigate Kubernetes networking challenges effectively. Thank you. I hope this talk was beneficial to you. Please feel free to reach out to me using my LinkedIn and feel free to check out the Cloud Networking Configuration Solutions repository using the link here or the QR code. Thank you. Have a good day.